did you know that 9 out of 10 endoprostheses in the world have been manufactured and are being manufactured on Monnier Zahner machines? Fabian, thank you so much for inviting us to talk about this M682 MEDICELL. But first, what is an endoprosthetic?
When we talk about endoprosthetic, then we're talking most of the time about hip implants, shoulder implants, or knee implants.
Yeah. And these components, I guess they need really complex processes to make something that's going to go in the human body.
Yes.
What kind of processes do they need, and what does this machine do?
So most of the time there are many different processive steps which are needed to do. Here we are talking about the hard machining part to produce such endoprosthetic.
Yeah, and those machines, hard machining parts is kind of ceramic components,
yes,
hard materials. So grinding is what we're doing here. But there's lots of different types of grinding processes. What are the kind of, lay out the ones that you do on an endoprosthetic?
Okay, here we have a MEDICELL. So then we are talking about the machine bases which can carry the taper grinding, chamfer grinding. So then we have all the internal parts are done. Then we can talk about the spherical part, like grinding and polishing. Depends a bit on the material, what needs to be machined. And as well some contour polishing if there are certain parts which need to be additional polished.
So this is a kind of like a platform machine that can take on different configurations.
Exactly.
But a customer that would be using these machines would have them in a line, I guess, in like a production line.
Yes.
What kind of volumes would they be making, and how much is their mix in the process?
It depends always on the cycle time of the machine, how many machines per option really are needed. Most of the time all the machines are connected together, like with AMR system, conveyor magazines, so they can dock on the machine cell, like here is the MEDICELL, and then pass them along to another machining process, let's say the SG version.
Yeah, so the automation between machines is really important, but there's also a lot of automation inside the machine as well, with tool changing and workpiece changing happening at the same time. Why is that?
Because to make the cycle times as short as possible. So we always have to take care about the downtime of the machine. So there are many tools are in it, like 20 tools are in the machine, and in the magazines are multiple parts to be exchanged. So we need to make sure that the robots can change tool and workpiece together to bring down the downtime of the machine.
And I guess that's because these are such high value parts, making them in an automated way with as little downtime as possible is about maximizing the value for the customer.
For sure, yes.
Cost per part.
Yes, for sure. That's exactly the target.
Amazing. And when it comes to medical components as I guess critical as these that will be going in a shoulder or a hip, how important is traceability?
That's one of the highest points what we have to reach. So we have many different sensors in those machines, like there is a force sensor to control the force of the actual grinding operation. There are temperature sensors in it, vibration sensors, and every of those data can be traced with one single part and get back to the ERP system of the customer.
Amazing. You can see some of the sensors, there's at least 3 just in this small part here, and they all get used depending on the different type of component, and you're showing us spherical grinding here. It's a really complex machine. It's an amazing platform. And these all are produced, basically, almost all of this machine is produced in-house, pretty much, the ones that you'd expect.
Exactly. That's our KPI, let's say it like that. So everything what you can see here is basically made in-house. So we do the electrical wiring, we do all the steps of development, like technical, electrical, software development, everything is done in-house.
Yeah, and when it comes to programming this machine, it looks complicated. There's lots of axes going on, 2 different robots as well. How do you try and make it easy for an operator to get to grips with the control and make sure they can set it up and get it running as fast as possible?
Yeah, that's based on our experience, what's really needed from the market. So actually we just try to take care that it is a complex machine, but we try to keep it as usable as possible. So we always work with parameters, so it's a dialogue control. The machine always asks which parameters are needed to fulfill the process.